All right, page 103. So we used the TBM calculator on our calculators to figure out that Josephine needs a little over $300,000 to have $1 million in 50 years. So that found our present value. Let's see what other things we can find using this solver. Here's a spoiler. It can find anything on here that we want. So let's see what number 4 asks us for. So it wants to find the future value. So right away, we're looking for future value. So we're going to draw a box around the future value, so I know to highlight that and help us all there later. So let's find future value of an investment of $6,000. So that is the present value, and he is investing that. So we want to make sure that's negative. It earns 6.25%. 6.25% goes in the percent. Remember, we want to keep it as a percent here. And it is compounded quarterly. Quarterly tells us that N is 4. N is in 3 different places. It is here times the time, and that was totally a 4, not a 3. It is here times the time, and then it is also in PY and CY as well. And his time is 35 years, and time is 35 years. We'll have to calculate that multiplication for us. Payment, we won't see any payment for another video or 2. And then only when we see annuity will we have it again. We'll learn what that is in a couple videos as well. So we'll make sure end is highlighted as well. So work with me here and type in everything to your calculators. 4 times 35 ends up being 140. That's cool. 6.25%, negative 6,000, 0. We don't know, so I'm just going to leave the number there. Oh, I missed it. PY and CY changed to be the same. And we want to go find the future value of this investment, so I make sure I'm highlighted there. Hit alpha, enter, and it tells me that he's going to have just over $50,000. So he's going to have $52,580.51. Be sure we're rounding to 2 decimal places because we're talking about money. I like to have a little sense answer for each of these scenarios. So Reginald will have $52,580.51 in his account after 35 years. So just a little sentence that proves to your teacher that you understand what you just found. So we'll have that future value in his account and after that many years. Let's move down and talk about Hilda. Hilda wants to have $10,000. So she wants $10,000. That's her future value in 10 years. That's our time. So our future value, we can fill this in, $10,000. Time will be multiplied by the compounding periods. After investing in an account that earns 3.6%. So that's our interest rate, compounded monthly. So that tells us that N is 12. So we put it 12, 12, 12. And then we want to find how much she wants to initially invest. That is the PV, principal, or present value. So we want to draw a box around the PV. Payments going to be 0, and we need to, and if we were making payments, they'd be at the end. So when we go from the top here, type all that in, 12 times 10 ends up being 120, 3.6%. We're going to go find our present value later. Future value, we want her to have $10,000, compounded monthly. If you watch when I hit enter, the CY will change to match as well. And then we want to go find her present value. So she needs to invest just under $7,000 to get that $10,000. So we write negative $69.80.52. And so we say to answer the question that Hilda needs to invest $6,980.52. So that she'll have $10,000 in 10 years. So what I want you to do is I want you to continue this and try. On the next page, we have Juan and his scenario. Good luck.